The search for extraterrestrial intelligence. In the last couple of lectures, we looked at the Drake equation and we looked at both the optimistic and the pessimistic view on whether there would be any intelligent creatures out there right now that we could talk to. And keep that in mind, right now is part of the equation. Remember, there could have been civilizations long ago that lived and flourished and sent out signals, and they vanished. Maybe they destroyed their world, and we'll never know. But right now, is there anybody out there for us to communicate with? Obviously, we don't know, but we've been trying for a while. Now, keep in mind, even if we found a signal out there, we're not going anywhere anytime soon. We still can't even travel to the closest star 4 light years away. Even if, in the most optimistic view of Drake's equation, there were 1 million advanced civilizations right now, they would still be spaced 100 years apart, 100 light years apart on average. So keep that in mind. And of course, that's a wildly optimistic viewpoint. Anyway, at our moment in history, we haven't mastered interstellar travel, not even close at this point. Maybe we'll find some way, some shortcut of physics that will allow us to travel, and maybe the aliens have figured this out already. That's kind of what we have to hope for. But right now, with our current technology, it would take us 50,000 years to travel to the closest star system to us. To go that 100 light years away, it would take us 600,000 years, which is kind of depressing. So we need to understand physics a little better and to be able to engineer a way to travel amongst the stars. Now, I want to mention something called the Fermi Paradox. In around 1950 or so, Enrico Fermi, who had worked on the Manhattan Project, was the leader of that. He asked a pretty simple question. He said, look, those of you that think that intelligent civilizations should be out there all over the place, why haven't we heard from them? Why don't we have evidence that they exist? Why don't we have evidence that they've already, spread out throughout the galaxy? Because in this speculation, he said, look, once you get sufficiently advanced, in just 10 to 100 million years, you could have colonized the entire galaxy by now. And our galaxy is billions and billions of years old. So there should have been sufficient time for very advanced civilizations to thrive and to colonize our galaxy. And we don't have any evidence for that. So why aren't we hearing from them? If that's the case, if the universe, if our galaxy is so old and so forth, and so many opportunities, so many stars, so many planets, then why haven't we heard from them? That's tough. It's a tough one. Because we haven't heard a signal yet. Now, here's another big question for us. Do we really want to contact an alien civilization? Because we're very new. We're a young civilization. It's only been 100 years that we've had the technology to send out radio signals. 100 years. What if they've had that technology for 1 million years? What if they're 1 million years more advanced than us? Do we really want to find them? What's the history on Earth when a more primitive civilization is visited by a more advanced civilization? Well, it's not good for the primitive civilization. That never seems to work out well. They have a really good debate about this in the movie Contact, where they talk about what it would be like to contact someone way more advanced than us. Would they be nice to us? Would they, how would they feel towards us? But anyway, this is kind of funny. On some of the first spaceships that we sent out that we knew would leave our solar system and millions of years from now could be intercepted by aliens, we did some interesting things. We sent out a gold record on one that had people in all different Earth languages saying hello, played some music, classical music, and some early blues. They sent out this plaque showing a couple people there saying hello, and interestingly enough, providing a map of our stellar neighborhood and of our planet and where we're located. Quite recently, Stephen Hawking came out and said, look, this is not a good idea. You really don't want to signal that we're here. We should really keep our mouths shut and hope that we're not found, because again, chances are they will be much more advanced than us, and who knows, maybe they'll like Earth for our abundant water and energy and things like that they might like. So who knows? if that's a good idea or not. But in the meantime, we have been scanning the skies passively, and in a couple cases, we've actually sent out actively radio signals for them to find us. Again, maybe not a good idea, but we've been listening for a long time, and we've been listening in radio. Why radio? Well, it's cheap. Radio travels well. It penetrates the dust and gas of the galaxy. It just seems like the obvious way to go. Some SETI searches, SETI being the search for extraterrestrial intelligence, some SETI searches are now looking for things like optical laser pulses and other things other than radio. Now, our radio signals have been sent out now, again, for the last 60 years at least, really 100 years, but maybe 60 years if you look at pretty strong signals. And in that 60 years, you can imagine a bubble of radio extending farther every year and going past more and more stars. So already our signals have gone past 1,000 star systems plus. And it's interesting to note, to think about that as our bubble of existence expands, more and more civilizations, if they were out there, would be aware of our existence as this bubble reaches outward. That's what happened in the movie Contact. Of course, our signal finally reached the Vega system, and they sent back a response. So where do you look in the whole vast radio spectrum? Well, one place you would look for signals is what's called the water hole between hydrogen and the hydroxide. For whatever reason, they believe that would be kind of a natural place to send a signal. It's kind of a lull there where you don't have interference from other things. That might be the place where you would look. Anyway, SETI's been around for many, many years, and they've had different sort of phases they've gone through, different projects. Project Phoenix in the 90s, where they look. They've had SETI at home, where people in their home computers use their home computers to help search for these signals. And most recently, they've gotten use of the Allen Telescope Array. Paul Allen, the co-founder of Microsoft, provided the funding here for this array of telescopes to search the skies, to continue to sweep looking for that signal. And even though they haven't had success in all these decades, all it takes is once. All it takes is that one signal to change everything. So I definitely root for SETI, and hope that one of these days we will get that signal. Here's a little clip here from the movie Contact, which of course is about us getting that signal. And in the movie, Jodie Foster is the astronomer working for SETI. Oops. And of course, for dramatic purposes, they have her out instead of, just the computer searching for the signal. They have her out listening at the radio dishes, which is kind of silly. And but anyway, it makes for a good dramatic moment here. There's the signal already being read on the computer. They're not really paying attention inside, but of course she's going to start hearing it through her earphones there as they get the signal. So, again, that's Hollywood's version of how it might happen. In reality, it would not happen quite that way, but one way or the other, a signal like that, that's what we're looking for. And they've had some interesting signals before, but nothing obviously has panned out just yet. So she hears the signal. She's going to jump in her car here and head on in and let the world know. All right. When that happens, we will have a new phase in human history. And it's just fascinating. I love history, and I love to study how humanity has evolved from learning agriculture and the first cities and mathematics and the development of science and through everything. I love this little timeline here showing everything, and really the birth of modern astronomy with the telescope right on up to the development of nuclear energy and now the internet and all of this. But if you think about it, that would be a milestone unlike any other. When we get that signal and we finally confirm that we are not alone in the universe and not alone in our galaxy, and the implications are so profound. Until that day, we are adrift here on Spaceship Earth on this pale blue marble. And you look at the void around us, and it makes you want to take care of that little lifeboat that we're in. But it's nice to think that that signal, the signal that changes everything, could be on its way right now. I'm Kyle Jeter. I thank you for listening to this lecture, and if you've been following this course, I thank you for following along. There's so much more to know, and I encourage you to go out and read more and learn more about the wonderful universe in which we live. Take care.